Thank you, Matthew. I'd also like to thank Marsha for the invite. She saw me give this at Primex at Casino earlier in the year, so she thought it was relevant that I deliver it here at Brahman. So, as Matthew said, I'm going to give you a progress report on where we're at with the Southern Multibreed project. We're currently 4.5 calf crops in, so we're right in the middle of our 5th calf crop being born at the moment. Yep, thank you, Marsha. So to start this, I want to set some context around why the project exists. And you would have heard, it was been mentioned before, Repronomics, David Johnson runs that in the north here, and I think everyone should be aware of it. But something that's evident in that is that the value that's created by genetic variation. And if we look at a group of steers that were produced out of Repronomics, Brahman steers, the highest and lowest value Brahman steer in that group, the difference was over $1,500. And when David sunk that back in and looked at what were the sire averages across that group of steers, the difference between the best and worst sire is over $500. When he does the same thing, looking at fertility in a different year group this time, but looking at fertility in daughters, when they assess it on the basis of does a female stay in the herd and breed twice successfully in 2 years in a row, there's a 49% difference between the best and the worst sire. 49% of them do 2 from 2, and when he takes it to the sire level, the worst sire, only 15% of his daughters got 2 from 2, while the best sire, 75% of his daughters got 2 from 2. So in these sorts of research projects where we're looking at the fundamental genetics of the populations, you can see that the productive characteristics driven by those genetics actually have on-farm dollar impacts. And for organisations like MLA, what they want to see that driven through is changes in profitability on farm. That's what the Commonwealth Government assesses it by, and it's driven basically by what is the genetic trend in the indexes across time. And what I've done here, this is for southern Australia, but the same concept I think applies in the north. That I did it for the breed plan run 23, so I presented this in Western Australia at a genetics conference last year, but the genetic trend across 23 or 4 years from 2000 onwards was about $2.79. 8 years before that, the former director of ABBA, Robert Banks, did the same thing, and he got the estimate of we were improving by about $2.83 a year per cow mated. Now that hasn't changed. His estimate finished in 15, my estimate finished in 23. So in that 8 years, we hadn't actually increased the rate of genetic progress that we were seeing in the industry. And that's where MLA, even ANPC, are investing money to see us do that. So that's the driver behind why we want to do these projects. And I think one to take note of is that in the south, there are individual herds over an extended period of time that go at better than $5 a year per cow mated. So they're actually making substantial genetic progress, close to double what's going on average. And in some cases, a lot more than double. So the Southern Multibreed project, we designed it to do 3 specific things to help us try to increase the rate, help the population of breeders increase the rate of genetic progress. And that's what I try to represent here with our 3-pointed crown. The first one, aligned very nicely with our Repronomics, is when we're selecting bulls currently, we're basically selecting within breed. And we possibly do that well, I would think we do from what I've experienced, but when we want to do comparisons across breed, in our current evaluations, it's non-existent. We can't do that. Main reason is because the data that's recorded to drive the genetic evaluations is recorded in breeds that are segregated in the environment. This stud over here is Hereford, this stud over here is Brahman. They're not run in a common environment. You can't compare them because the environment is confounding. What we want to do is contribute data to actually change that. We want the breeds in common environments, and that's exactly what David does in Repronomics. So the environment's no longer confounded and the differences are only due to genetic differences between breeds and between sires. So that's the first prominent point of the crown. The other part is that there's no point doing this work if we're not breeding for the future consumer. And Michael touched on this in a lot of his presentation, and I'll show you something in a minute that's actually an old version of what Michael's already shown. I need to get it updated, but we're looking at traits that are actually going to meet what's going on in terms of our changing demand and expectations of the consumer. So one of the things that MLA found in some of their survey work was that we're not actually, as a population, reducing our red meat. Michael touched on this consumption, and it's actually remained stable for over a decade before this survey was done. But those that are reducing it, the two main drivers are price and health perceptions of red meat. Now, that's changed slightly in what I saw Michael present this morning. And as I said, I'll need to update these slides. But the other part is that some of them have an environmental concern and a welfare concern, and that was pretty evident in what Michael said. So that's what we're doing. The so what is we're actually trying to record more than what breed plan does, so we can consider new traits to come into the system, so we can have new EBVs that breed for the future profitability, not what's currently profitable. And so I've tried to indicate that here. So a lot of these are things that are currently in breed plan in many facets. You've got weight, yield, reproduction, shear forces and meat quality trait, marbling, feed requirement. NFI is a trait that's in some breeds, not in all breeds. But the new future drivers, things like environmental sustainability, disease and parasite resistance, resilience of the animal and welfare at a much higher level, are things that we're actually recording through the project. And I'll touch on a couple of them a little bit later. And the third very important tier is that if we're going to invest in doing multi-breed and we're going to record current and new traits for the future, we're going to take advantage of all the technology. So everything is being DNA sampled. Brahmins became the first breed in this country to use single step, which means all your EBVs are genomically enhanced as it is now. So we're taking advantage of that and taking DNA so that everything can lever off that advancement in the EBV technology. So if you want any more questions about that, I can take them later. But I want to quickly go through the design so you understand what we're doing, because I want to get into some of the things we've seen now that we've started to get some data. The project is run across the state of New South Wales, 5 locations. We start at Grafton, where the Brahmins are, because it's highly relevant there. We go into the Northern Tablelands at Glen Innes, out west to Trangie, down south to the Riverina at Yanko, which is near Griffith, if you're not sure where that is. And our fifth and largest site is Menangle. That's Elizabeth MacArthur Agricultural Institute. That's the first place in Australia that agriculture was undertaken. There's 550 cows there and 4,500 acres that they use right on the edge of Camden and Campbelltown in southwestern Sydney, just before you jump over the hill to go into the Southern Highlands. Just so you know, this is a rough idealised setup of how the project works. We're aiming at about 2,000 cows calving a year, roughly distributed like that. It hasn't always been like that. Weather 2019 put a big dent in us, and we've balanced things around. The reason we chose those sites is we want the genetics to not just be performing in one location. We want to challenge them in terms of environmental differences and time differences. So here we've got 2 photos. The top photo is a group of Wagyus out at Trangie in the middle of December, January, and close to the same days the Brahman, Hereford and Angus at Grafton, summer pastures. So you can see we've got what we call temporal or locational differences in the challenges of the genetics. And these 2 photos here are actually paddocks next door to each other at Glen Innes, 4 months apart. This is March, a lovely turnip crop. This is the middle of June, -8 in the morning when they were measuring the calves on the ground. So we're comparing spatial or temporal differences versus time differences within and between sites. 6 breeds involved, the 5 biggest influencing breeds, and they influence over 80% of the genetics in Southern Australia: Angus, Charolais, Hereford, Shorthorn and Wagyu. Brahman is our 6th breed. It's highly relevant in the northern parts of the state, particularly the North Coast, and it also links to the Repronomics project. We've collaborated at a high degree with David with bulls and semen and everything else that we do. And David's actually started, I'll get onto it later, but Dave started to use some of our semen in the Repronomics project. How we quickly do this, we're only really interested in purebred matings predominantly. You notice there's a hash there, I'll touch on that in a second. Everything is designed mating, because one of the big things we're doing is looking at new fertility traits, and the quickest way to erase fertility is to become inbred. So that's all designed. And the idea is to produce comparable progeny. So everything goes in together and goes out together. There's no drafting. We don't facilitate any conventional on-farm activities. It's all comparable at a genetic level. So it's all in, all out mentality. A little asterisk is we do a little bit of crossbreeding at Grafton specifically. First of all, because crossbreeding is highly relevant in Australia, but it's even more relevant on the north coast of New South Wales. The old Grafton research that was done down there in the 60s and 70s really made the F1 cow a high value commodity. So what we do down there is we breed the Brahmins to the Hereford and Angus. We don't worry about the black Ballies. We do a level of crossbreeding while still having those 3 purebreds to make comparisons to. And here's some photos you can see here, some of the young calves born. The first F1 to calve a couple of years ago, and our F1 steers mixed with the other steers before they went into the feedlot. And everything, as I said, is managed head to head. So there's a photo from Grafton where we've got the Angus, Hereford and Brahman. That's a photo from Glenanus, Angus, Hereford and Wagyu. This one's Trangie again. While the drought, we're just coming out of the drought here. At that stage, we only had Angus, Hereford and Wagyu, but now we have Short-on and Charolais at Trangie. And we have all 5 southern breeds. That's the EMAI site, and you can see that up there. That's the phone tower and the water tower for Camden municipality. So there's houses actually just along behind those trees right there. That's suburbia. And there's the steers, some EMAI steers, and then some Grafton steers in the feedlot. The Vitelli feed machines there that we're doing NFI testing with. All right, that's a quick run on design. If you want any more questions, you can ask me later. I want to show you where we're up to so far. So if these are the main events within the project in a given year, the animals are born, weaned, etc., right through to their second calving. We're currently sitting at this point here. Our first cohort females have actually been AI'd last year and having AI calves this year. Our cohort 2 females are actually having their second natural mated calf. Cohort 3 are having their first natural mate calf. Cohort 4 we weaned in April and they're mated in October, natural mate again. And as I said earlier, we're right in the middle of carving down our 5th cohort at the moment. Just to show you some of the things that we've achieved in terms of the design, that there is the total number of bulls per breed that have been used in the project. In the first 5 matings gives us 456 different sires that we've assessed in the project. Those sires, a number of them have links to David's Repronomics project, the old beef CRC, and then that's probably needs updating now, but there's bulls in there, Hereford and Angus sire benchmarking programs. The box in the middle, I just wanted to show you what we do. What I've got here is the 5 sites. You'll notice Tokal is there. It's actually now Yanko. The cows have been transferred. But the bolded on the diagonal is how many sires we've used at that site, and the numbers on the off diagonals are how many sires are actually being used in common between the sites. So our mating is designed both AI and backup, because some of the backup bulls actually rotate between sites, but it's designed to actually, as I said earlier, expose those genetics to different environments to test them. We don't want to be soft on them, we want them to perform. And out of that, as we currently sit, we've generated, as of Tuesday, nearly 7,500 progeny. As I said, we're part way through carving down our 5th group. There's a rough break up there between steers and heifers, but you can see that we started at low numbers and we've ramped that up since we've come out of the 2019 drought. Just to give you an idea of the recording of traits, there was a stat we created, I think it was in March this year, that in the project at that point we'd recorded over 100,000 different individual phenotypes in the project. And that's just an idea. You can see we're currently sitting over 7,000 birth and calving age records. We've got close to 5,000. Oh, I'll press that one again. 5,000. We've got over 5,000 of those early life records. We're getting close to our 5,000 for the growth and scan traits. And you can see the sex-specific traits, whether it's carcass traits or fertility, we're down a bit because you halve your numbers and then you lose animals as the project goes on. But we're making progress. That's every year that's increasing and helping us. So I wanted to show you some of these are raw values for our environments, so please don't take them as me saying this is applicable to your environments in Queensland, but this is what we see in the project. I want to touch on birth weight because it's a really interesting one. That's the distribution you can see there recorded in the project. And Our range is an 8 kilo viable heifer. She grew up and actually conceived a calf and calved in the first year, to a 72 kilo steer. That's our weight range for birth weight in the project. We're averaging about 38 kilos, which is pretty reasonable across the breeds. And one thing to note, that all breeds have a birth weight that's lower than there, and all breeds have birth weights that are higher than there. It's not all Wagyus at this end and Charolais at this end. The breeds are actually highly dispersed in where the data is. So there's Brahmins that are actually got birth weights lower than 35 kilos, and yet there's Wagyus that have got birth weights higher than 40. That's the common theme. We are seeing massive amounts of variation within each breed in the project. This side here, I'm just showing you that we get sensible results. I've broken it steers and heifers, what they look like. The mean is the black line is the mean in steers, 38s overall, and there's about on average a 3 kilo difference between steers and heifers. That's about consistent with scientific findings, that 3 to 4 kilos between steers and heifers is consistent. So that gives me confidence that we're doing something useful. Hang on, sorry. What I've done here, is I've now gone in and focused on the Grafton data. So the not BB, what that means, it's a Brahman cow who's been mated to a Hereford or an Angus bull. And sire BB means it's a Hereford or an Angus cow that's been mated to a Brahman bull. And that's the mean birth weights between that combination of matings. They both produce crossbreds, but you see that there's now a 6 kilo difference. That's important because if we've got a Brahman bull and we want to mate him to a Hereford or a Brahman, he actually needs a different EBV if he's mated to a Hereford than if he's mated to a Brahman. The background of the cow herd is actually important in this context because there's dichotomy between the effect of the bull. We actually had an American visitor earlier in the year and he was talking about this, so I did it further. I've now broken those two categories up into what is the birth weight of the heifer and steer when it's not a Brahman sire, and what is the birth weight of the heifer and the steer when it is a Brahman sire. And again, there's our mean. There's only a 1 kilo difference between the birth weight of the steer and the heifer in the crossbred when it's not a Brahman sire. But when it is a Brahman sire, the males are 6 kilos heavier than the females. And I think it's only a 1.5 kilo difference between that female and these two here on average. So what we're actually finding there is that the effect of the male Brahman bull is different if it produces a male calf to another breed than if he produces a female calf. And the effect of the male of the Brahman bull is different if he's mated to a Brahman cow than another breed of cow. That's significant because it means the bull's genetics are not being applied equally in a different mating scenario. And if we're going to produce future genetics, we need to be factoring in that into how we actually communicate that to people. Moving on, just show you a bit of growth information. This is age, that's live weight as we record them 2, 4 and 600 days. The different lines mean different things. The two purplish lines are the crossbred performance. And on average there's a 50 kilo advantage in the crossbreds, which is about a 14% hybrid vigour advantage. Now in the research they did at Grafton in the 60s and 70s, their number was 11. So we're pretty consistent with what they've done. And just to show you, the vitelli machines, they'll grow safe in the days the photo was taken, but you can see there's some Brangus crossbreds, some Hereford Brahman crossbreds, and you'll see the other purebreds in the background there. Out of that, they go through approximately 100-day feed at Talimba. They do 91 days on a feed test, then we give them 10 days so that we try to maximise their meat quality, and they get about a 100-day feed. What I got up here is the carcass weight and MSA marble score outcomes between one of the purebreds, that relevant cross, and the Brahmans. There's a few things you can see there. First one is there's a big amount of variation in the marbling in the Brahmans. It's actually bigger than the variation we see in the crossbreds and the straightbreds. It means there's potential there to breed for it. The other one, it was in that graph about the hybrid vigour advantage, but you can see the growth difference. The carcass weight at the same age, they're all managed as a contemporary group, You can see the difference that's been expressed in the growth potential there, and you can see the difference between the best and the worst within each of the categories of animals. That there are Brahmins that grow better, there is an advantage of crossbreeding, but there still are the purebreds that grow well and don't grow well at the same time. They're all at the same age, so they're comparable by age. So there's variation there to breed for both growth capacity and marbling in Brahmins and in the purebreds to produce a better product in the crosses. I thought I'd show you this one. This is the ossification score relative to carcass weight in the same steers. And effectively there's no difference in ossification between whichever combination you like. It's really just the growth capacity. So, Michael mentioned it earlier about the ability, weight for age in the MSA model. Those two graphs are just showing you that you're not going to get any advantage in ossification. It's around weight for age. If you can get them killed at a higher weight at a younger age, you're going to get an advantage through meat quality outcomes and less feed to get them there. You might like it, but that means less methane to get them there too. And that's what's going to come out of society as we move on. All right, I'll touch on some female traits. The new reproduction traits, David records these in Repronomics: age at puberty and first lactational and estrus, done by ultrasound scans. Images there, I think that might be you there, Paul. Critically here, the breeds and crosses are in the same environments. So they've experienced the same thing. So what I've got here is age at puberty as determined by ultrasound, the weight of the female at puberty. Just to give you some production context, that's when the bull goes in, that's when the bull goes out. We're breeding in a southern system. They're mated at 15 months of age. They're mated for 63 days. We want to push them hard. We want to see the variation in their genetics. You can see there that most of the crossbreds in the purebreds cycle before the bull comes out, and the Brahmins, there's a trajectory. There's a 14% hybrid vigour gain in days at age at puberty in the crossbreds, whereas that hybrid vigour effect is only 3.5 in terms of weight. That means there's really no weight advantage in crossbreeding. It's just that they grow quicker and get there at a younger age to reach puberty. And you can see there that these Brahmins are about the same weight as these crossbreds and purebreds when they're actually cycling the first time. And if I just pull out the Brahmins, you can see there's a segment of Brahmins actually have the ability to reach puberty before the bull leaves the paddock for mating. There's a segment that doesn't. So again, there's variation in the breed to actually improve fertility, to get them pubertal before the bull disappears. Now, that may not be completely relevant to your systems, but the point is that there's still capacity to breed for fertility. And the earlier they're in calf, the better their lifetime reproduction and lifetime productivity is. I'll go to this one. It's the same thing, age at puberty at the bottom, but up the side is weeks pregnant as diagnosed by the vet at preg test. And you can see there's a number there that aren't pregnant, and these are the ones that are. And you can see with the Brahmins in particular, there's this declining trajectory as the older they are when they reach puberty, the later and later they are in pregnancy. The other point is that puberty doesn't determine pregnancy. Puberty is just one facet of why they become pregnant. You can see there's a number here that were cycling before the bull left, but they still didn't actually conceive a pregnancy that was carried to preg test. So puberty is important, but it's not the whole game. There's other factors, but the point I wanted to show you here is when I put weight at puberty, there's no relationship there compared to age. You can see the green dots have got a nice slope coming this way, whereas there they go straight across the page. So again, it's how old they are when they get there. If they can grow quicker to get to the same point, they're more productive and it's a better outcome. That's what we're seeing anyway. But I thought I'd show you an Angus graph from one of the other sites. This is not Grafton, but what I wanted to show you here is the relationship between the traits. So age at puberty, and on this axis here, it's how many days post-calving they go through the lactational and estrus. If I pick two Angus females there, they've only got about a day difference in terms of their puberty, but there's 2 months difference in terms of their ability to recycle post-calving. Pick another Angus heifer in comparison to that one. There's 6 days difference in terms of their lactational and estrus period, but there's 185 days difference in terms of their pubertal measurement. So the two traits are not correlated one-to-one. If you measure puberty, it doesn't mean you're measuring lactation and estrus, and there's scope for us to breed for the two of them, and we're actually working on that inside ABBA at the moment. Just to put context, they're just the dates. The heifer bull went into the paddock the first time, so everything on this side was risking not going in calf. And then this is when the bull went in after they'd had their first calf. So you can see there's a lot of females above that yellow line, even in a southern production system, that are at potential of not calving the second time. And that's often a misconception in the south. You don't have to worry about fertility. As the environment changes, fertility is going to become more and more important, as it is for Brahmins now. Just a couple of quick little ones. We're doing horn pole phenotyping. On the left for you, we've got pole Wagyu at the top and a horn Wagyu at the bottom. We've found skirt Angus in there. We've also got the full trajectory of polled, horned and skirt Brahmins, Herefords, sorry. So we're recording that, and we're phenotyping at multiple points in the animal's life to help us refine the horn pole test. Immune competence, a resilience trait. I don't know if I've ever seen it before, but when I look at the breeds, hang on, what did I do there? Sorry. That one. The two different parts of the immune competence test. You can see that breeds A and B here, in particular, have lower levels of cell activity, but yet they have a higher level of antibody activity, and that's a new thing to us, something we've got to explore further. It's just a quick finding that we've got now. And just to wrap up quickly, I haven't updated that number, it should be 7,400, but we're into our 5th calving. I showed you the number sires. I must have updated this in April, over 120,000 individual records. That'd be close to nearly 150,000 given we've got calving going on at the moment. That's usually our high point. 6 of the traits we're recording are non-breed plan standard traits to try and expand that quota of traits. There's 4 linkage projects. One is methane measurement, so all the heifers are being measured in the paddock on grass for methane and all the steers in the feedlot for methane. And just on Tuesday, I wrapped up all the 400-day data for the first 3 cohorts, so it's in a position that we can start to look at what happens when we integrate that data with the within-breed genetic evaluations for breed plan. So that's starting to roll more now. And just, I suppose I wanted to reinforce the value of these projects. This is the genetic trend. It's a couple of years old now in Brahmins for days to calving as a result of the beef CRC and repronomics research projects. Those projects have actually been able to assist the Brahmin breed in changing the fertility profile in a relatively short period of time. I think this is something like 2016. That's like 2009. So these projects are valuable at an industry level. And just to finish, I want to acknowledge a lot of people. I can't do this by myself. There are many, many people involved, including our partners, Zoetis Neogen, Apex Breeding, Bovine Scanning and Holbrook Veterinary Service. They're contractors, but they're essential to the activities we undertake. If you want to see more, you can Google, use the web link, use the QR code. I can send that to Marsha and she can share that. That's a website. The last one I want to do, very important, Jason Siddell was my offsider. Some of you would know him. He bought cows off some of you, bulls off some of you. He passed in May from esophageal cancer, 42 years old. He was integral to this project occurring, and it's not appropriate I talk about it unless I acknowledge him and his contribution. He's dearly missed. He was a big part of what we've achieved thus far and what we'll achieve in the future. Thank you very much.
Thanks, Brad. Well, as I seem to have started off by asking the first question, you had a slide there that had age of puberty not necessarily linked to lactation and estrus.
Yep.
I thought that was a strong correlation between age of puberty and returning to cycle loss there.
Yes. So that's something that we're seeing, a contrast between repronomics and SMB. So that is, there's no...
They're Angus cows,
no, Angus, Hereford and Wagyu, just the ones with the pink circles are Angus. So David's repronomics project in the northern breeds tends to see a positive relationship between the two. So a trend that goes more like this. We're not seeing that in our southern breeds. I have to put a caveat on that and say we need to do a lot more work in this. This is only really raw, really. But we're not really seeing a stronger relationship as David sees, and that could be environmental. So we just got to look at that further to pull more out of it to see exactly what's going on.
Thanks, Brad.
No worries.
Any more?
Can I ask, were all breeds represented at all environments?
No. No, it's not relevant.
That's a bit of a worry because, as you pointed out in training, it gets very dry.
Yep.
And if you don't have many Brahmins there, you may be missing something.
Yes, but we're relying on the fact that David's got Brahmins up through Queensland and the Northern Territory. So Angus is everywhere. Yeah, but you don't find Brahmins in a high concentration at Trengi. The highest concentration in New South Wales is the North Coast, and that's the most relevant environment. And we don't have, even though I work for the government, we don't have endless resources, so we have to constrain the design at some level, and that's the constraint. Brahmins are on the North Coast because that's the most relevant, and it already links into Queensland. Angus and Hereford are across the rest of the sites, and then Charolais and Shorthorn, we have to disperse them, and Wagyu, depending on what we're capable of managing and running at each given site. Because we don't have endless resources, we have to constrain the design at a level, and it's done in such a way that Angus and Hereford act as our link across sites. And that's why it's really important that sire design I had, the sires are used between sites both as AI and backup. So bulls have been used at Trangie in Hereford and Angus that have been used at Grafton. So we get that representation that way.
You're not doing the opposite. You're actually missing out on one of the most important characteristics of Brahmins is that they're environmentally suited to drier environments.
Yeah, I agree with that, but we're also being highly representative of what's actually going on outside the research in the state.
Actually going on, but you're trying to do research.
Yeah, but that's also why.
Prove things.
But that's why it's critical the Brahmins are in repronomics in Queensland and the Territory. So
I understand, but New South Wales is a major beef state.
yeah, but not for Brahmin.
Only because this sort of thing goes on because you don't do the research that shows that in certain environments Brahmins are probably doing better.
Yeah, and if we had the money and resources, we would love to do that, but unfortunately we don't.
Change government. Maybe change government will help, Brad.
Maybe. Tom, I think.
Tom Coakley.
Thanks, Matt. Brad, you started off with some herds that were making genetic gain $5, which was a lot better. Can you enlighten us a bit on what they were doing? And then also the other thing about birth weight, is that linked back to the growth numbers on the bulls? And I'm intrigued also by the difference in the female weights, birth weights, and the male birth weights on the Brahmin side.
Yep. So those that are making $5 and better in the south are very systematic, I would say, in their decision making. They rely a lot on EBVs, but not solely. They also do a lot of visualised assessment and other such things. But they are very systematic in the way they make decisions and how they use EBVs and indexes to choose bulls in the process that they're doing that. They're not particularly chasing one outcome like marbling or fertility or anything, but just the way they use the information that's available, I would say from observation, is far more systematic than I see others doing it. The question about birth weight, does it link to growth? Yes, in part, but not completely. They're not correlated, one, but some bulls that have, it's not so much growth rate, it's perhaps more mature cow weight. Bulls that have bigger mature cow weight tend to have bigger birth weights. But they are related. They're not, correlation's not zero and the correlation's not one.
Gestation length tied in there? You'd have
Yes.
to stuff on that.
Yeah, it's consistent with what we know from longer gestation length, bigger birth weights. Yep. There is a hybrid vigour effect that the crossbreds on average tend to have bigger birth weights than the purebreds. I didn't put that in there. I have in the past showed the 3 purebreds and the crossbreds, and they tend to be higher. So there is a hybrid vigour effect on the birth weight. As for the Brahman sire effect on the steer versus the heifer, that's a new one to us. Like I said, that American fellow was out, I think it was April or May or something. And it's something that we've only just started to touch on, but there must be something to do. It could be related to gestation length. It could be related to the non-Brahman cow having limited capacity to control the feed or something. But something we have to explore further. So I can't give you a definitive answer there, but it's definitely there. You can see it. It's an effect, and it's something we have to look at.
Could I just have one follow-up on that? Because you've got multiple of those Brahman sires at different latitudes. Are you seeing the same effects at those further north, say Spyglass and other places? Is that irrelevant?
We haven't done that comparison directly into David's data, even though we can, because we're using some of the same AI size and linked backup size. But in his repronomics, he's actually seen the rankings of sires are consistent, but he sees, I think it's a 4 kilo difference between birth weight at Gander and birth weight at Spyglass in the same bull, which is, you would call that an environmental effect. But we need to do that more as time goes on, introgress our Brahman. And David's actually using some of our Angus and Hereford semen in the Brahmans in repronomics now, so we can introgress it more than the Brahman level. We can actually introgress at the crossbred level too.
I think there's like a 10-day difference in gestation between the top and bottom bulls and the Brahman bulls in that repronomic spread.
Might even be a bit more. Might even be a bit
Might be
more.
more than that.
Could be 10, 12 or 15.
Marie Copley.
Thanks, Brad.
No
We were
worries.
talking about in terms of growth and getting to your endpoint quicker, like
Yes.
you want to do. So in terms of growth EBVs, birth weight 200, 400, knowing that there's no single trait selection there, but what are you looking? So if it's quicker, is it logical that it's a 200-day growth, or is it
Yeah,
hard to say?
I would say that it's all of them, probably more so 2 and 4, but a balance with mature cow weight. Don't ignore mature cow weight. You need it to be at the level that suits your production system. So, yeah, there is importance of 2 and 4, but 6 would naturally be important as well. Maybe not so much, but the main point there is that you can see. Marsha, can you take that back to the age at puberty and weight at puberty picture, please? And probably just the one that's got the green Brahman dots. No. I don't know why it's not working at the moment.
Yeah.
Sorry. Ah.
There you go.
I'll go back to there. But you can see there, like there's a far bigger dichotomy. That's 350 to 820. There's a far bigger dichotomy there than what there is here. These two are probably exceptions, but you know, there's a tighter band around the growth in those Brahman animals than what there is their age at puberty. And that simply means that they're getting to the same size and weight, but it's just taking them longer. That's simply growth. So if you can get them to go quicker at a younger age, then they'll get there quicker.
Do you have an overlay on, excuse me, on that with the second calf? So
No, not here. No, I don't. But
so I think that would be
it's more composition. Yeah, it's more composition than weight at the second calf. So those that tend to have a better condition score when that calf's born, going into the second mating, they're the ones that tend to have the better reproductive outcome.
So you're hanging around, Brad,
Yes.
after this?
Yes, I'll be
Well,
here.
we just
all
got to
afternoon.
keep moving on, sorry, we do have a schedule, but you're happy to be available
Absolutely.
at the end of this for any questions. So anybody, I mean, there's no one more approachable than Brad. to talk to at lunchtime or when this is over. Thanks, Brad, very much.
Thanks very much, Matthew.
For your input. And,
Thanks, Marsha.
Yeah.